Okay, so for this question, we want to first find the area bounded by this. Y equals 1. Y equals 1 is a horizontal line here. X equals 2 is a vertical line. So we're talking about this area right here. That area rotated about y is equal to 2, which is this line here. Okay. So it's going to give us an area that looks like this. So a volume that looks like this. Okay, so try to imagine if that's rotated, you can see that we're going to get a hollowed hole in the middle like that. Okay, like that. Okay. All right, so how do we set this up? Now what we got to do is, okay, so for a particular value of x, okay, we got to find that cylinder, that thin cylinder, okay, and then subtract by a smaller cylinder inside. Okay, a smaller cylinder inside. Okay, first, the outer cylinder has this longer radius. Okay, this longer radius. Okay, so from here to there, let me call that y1. Okay, and the one inside is just really straightforward. Actually, it's actually a cylinder, right? It's just constantly one. So really, we can set it up like this. The volume is integration from 0 to 2, because this is 2 here, 1, 2, right? Pi y1 squared dx minus the volume of the cylinder is easy. It's just pi r, which in this case is 1 squared, times by height, which in this case is 2. So I'm just going to use the cylinder formula for the subtracting up the inside cylinder. So what's y1? y1, okay, this is how we're going to find y1. We first here, let me get some color. We first get this height, okay. If we subtract off the height of the exponential function, we actually get only that left over. Okay, so that's the idea. The height of from the base all the way to the line of 2 is just 2. It's constant, minus we're going to subtract off the height, the y value of the exponential function. So it's going to be e to the power of minus x. Okay, so that's our y1. So pi 2 minus e to the power of minus 1 squared dx, you get 2 pi. Okay, let me expand that. Pi 0 to 2, 4 minus 4 e to the power of minus x plus e to the power of minus 2x if you square that. Okay. Let's keep going. Let me continue here. 4x. Oops, I forgot to write dx here. 4x minus 4 e to the power minus 6. This is going to become plus. Okay, e to the power minus 2x. You got to times that by the derivative of this, so it's going to be minus 1 over 2. Okay, minus 1 over 2. In there, we're going to plug in 2 and 0 and multiply that all by pi. Okay, let's plug in 2, and you get 8 plus 4 over e squared minus 1 over 2 times e to the power of 4. Okay, plug in 0, you get 0 plus 4 minus half. If you plug 0 into the exponent, they just become 1, right? Okay. So pi times by. Alright, so the common base here, right, let me just write it all as a common base would be 2 times e to the power of 4. So it's going to be 8 times 2 e to the power of 4 is 16 e to the power of 4. Here you have to multiply by 2 e to the power of 2. So it's going to be 8 e to the power of 2. And minus 1 stays. Okay, and here we get 4 minus half. That's 3.5. That's 7 over 2, so it's minus 7 over 2. All right, so I'm just gonna, I mean, I can expand this a little bit more. Sure, let me just expand this pi. Pi, and we get 16. Yeah. So pi times by 16 e to the power of 4. Multiply that by pi, so you get minus 7 over 2 pi. So we're going to get a total of 11 pi over 2. Okay, so the pi is here and the e part's here. Okay, with this, of course, there's a pi here, but I mean, I think at this point we're meant to plug this all in a calculator and get a decimal value. Okay, in decimal, this is approximately 9.5, accurate to 1 decimal point.